Now that our device is configured properly, it is ready for development of automated test cases. TestQuest 10 leverages Microsoft Visual Studio 2010 Professional or better for its integrated development environment. One of the great benefits is the flexibility it provides by letting users select the .NET language they choose for development, such as C#, VB.NET, C++, Iron Python, and Iron Ruby. For this demonstration, we will be utilizing C#. TestQuest 10 has an integration to Microsoft Visual Studio such that I may view the device and connect the device through the toolbars. For example, if I want to go to enable the device pane, I can simply do that. It'll establish a connection and render the device pane. Through this interface, I have the ability to control the system under test, just like administrative mode in the snap-in. Let's go ahead and send a key back. And it does not matter if the device is local to me or maybe remote somewhere within my lab. There's also an additional feature called a search editor. The search editor allows us to identify the images and text strings we are looking for to provide that closed loop testing approach. So let's go ahead and connect with the search editor. As you can see in the search editor, here it is rendering the screen as well. I may pause the screen in the case I have a transitional dialog. In this case, I'll go ahead and pause it to stop the animation in the back. And in the right hand side, you can see all the different search objects I have created thus far to be verified or utilized in my automation. To create a new search object, for example, the menu button, let's go ahead and identify a region in which this menu button may occur. So I'm going to go ahead and select the region tool. I can come out here to the image and define a screen region. I can go ahead and save that region. I'll just say bottom third. Representing the bottom third of the screen. Upon defining the search region, I can go ahead and also select an image to find. I can simply use the image selection tool, come out here and draw a box associated with the image I'm looking for. I can go ahead and adjust the tolerance associated with that. So basically this is doing a pixel by pixel comparison on the RGB values. So if I have an image which may fluctuate in colors or in background, I can go ahead and adjust the tolerance to accommodate for those differences. And at this point, let's go ahead and save our search. And I'm going to go ahead and call this menu 2 image. I'll click save. At this point, it will render the search object on the right hand side of the screen. As you can see, menu 2 image is now available on the right hand side of the screen, and it's retained the values as defined in the search as a tolerance of 2, and it has a max number of matches, which is 10. In this case, that means there could be 10 occurrences on the screen. It has the image file it's referencing in the comparison, and the search region it is utilizing, and the coordinates associated with that. As a user, I may go ahead and choose to load this search. Once I load that search, I can go ahead and test it within the search environment to validate it is finding it properly on the screen. As you can tell by the moving animation around the menu icon, it is identifying the image properly. Upon using the search editor to identify the image search objects on the screen, users then can utilize those search objects in the code. Let's go ahead and open the device pane again. To begin, I'd like to share 3 simple commands which are critical to the part of the closed loop test approach of TestQuest 10. As you can see in the first line of code, it says phone1.screen.find phone icon. Basically what this says is search for the phone icon on the screen and validate it is true. Those commands can be wrapped into functions or test verbs, which are more representative of your manual test cases today. For example, I have 4 scenarios I've created, test scenarios I've created, that are very easy to read. I have a verify no SIM. For example, I'm looking to validate there's no SIM available or a SIM error on this handset. At that point, the test case will originate a call and verify the call failed properly. Second scenario is to verify the Wi-Fi is active on the device and navigate to a URL. So launch the search and then navigate to a URL called bsquare.com. And then upon completing that, it'll navigate back to the home screen. The third simple test scenario is to create a new contact, edit the contact details, and save that contact and navigate back to home. The fourth scenario is to test the functionality of addition in the calculator, which basically takes 2 operands, a 2 and a 4 in this case, and verifies the sum of 6. If any of these functions were to fail, it's simply catch the exception and go ahead and write the exception into the console application for the user to use. Down below are some of the code and functions that were created. As you can see, a locate image, tap image. These are basically helper functions which have been created to enable the higher level test verbs such as the calc add in this example. So if you look at the calc add, it's basically tapping on an image, menu icon, going to the calculator, entering the operand, verifying the operand in the search object. So in that case, it's actually reading the text and doing a verification. And then entering the text as well, operand B, and moving forward. And then eventually navigating back to the home screen.